Okay, so we're back at the top of page 3 of the Chapter 9 notes. We're going to start talking about factoring. And as you see at the top of the page there, factoring is breaking up polynomials into expressions that would multiply together to get you back to what you started with. So, for example, in last chapter, we might have had something like this, and we have to multiply. So we multiply this, we distribute, we get 3x plus 15. Okay? So we took it and distributed it. Now we're starting with an expression like this, or some that are more complicated, and we're going to break it up into things that multiply to be that expression. Kind of like if I ask for factors of 12, 3 times 4 are factors of 12 because 3 times 4 equals 12. In this case, there won't be all those different options, like 3 and 4 and 12 and 1 and 6 and 2, right? They'll just be 1. But it's that idea of going from this back to it being in parts that would multiply. We're going to see different kinds of factoring based on what type of problem we have. So the first kind, we're going to be factoring out a GCF, or a greatest common factor. So we're going to start out with an expression 5x cubed plus 20x. This is number 1 on that page. And we're going to look here for a greatest common factor. Common factor means it needs to be common to, in this case, both expression or both terms. But if the expression has 5 or 6 or 27 terms, if it's going to be a common factor, it needs to be common to all of those. So the better you feel about your multiplication facts, the more comfortable you are with them, the easier this part will be to just look at it and see what goes into 5 and what goes into 20. If you're not sure about it, then you can always do what we did from the first page and just list all the factors of 5, list all the factors of 20, look for the biggest one that they have in common. Okay, that's fine also. All right, so if we look at these, 5 and 20, what they have in common is 5. Then we're going to look at the variable parts. And we know from what we were talking about on that first page that x to the third is x times x times x. And x to the first is just a single x. So, again, we want to figure out what's the most number of x's that I can take out of both of those. So I can take one x out of each one. I can't do any more than that because this doesn't have any more to take out. And again, if I think about this, this has a 1 as my exponent. And as I said, the smaller exponent is always what ends up being your GCF for your variables. So it's going to be 5x. Now this is my GCF. Okay, this is my greatest common factor. It's the biggest factor that they both have. If I'm just asked for my GCF, it would be 5x. However, if I am asked to factor this, or to factor out the GCF, then I want to show that 5x times something multiplies to give me this part, right? So the GCF is only part of that answer. So what I have in here is whatever's left from up here. So if there are 2 terms in my expression, there need to be 2 terms in my parentheses because whatever's left over from the first term, whatever's left over from the second term. So there are a few different ways you can think about this. One way is to divide. I could take that 5x cubed and divide by 5x. And I could think about this. 5 divided by 5 is going to be 1. Cancels out to be 1. X cubed divided by x to the first. 3 minus 1 is going to be 2. So x squared. So that is what is left here. 1x squared, or I can just write x squared. Another way you can think about it is you can kind of think backwards almost. Kind of like we were talking about up there, that this times this has to give you this first expression, that first term. So 5x times what needs to give me 5x cubed? Well, I don't need another number, but I need x squared. So whichever way is more comfortable for you. Okay, now I'm going to take the second term, and I'm going to have 20x, and I'm dividing out 5x, or I'm factoring that out. I want to know what's left. Well, 20 divided by 5 is going to be 4. The x's are gone. So this is just going to be plain old 4. And that makes sense because when I multiply these, 5x times 4, I just need an x to the first power. So this is my answer in factored form. I can tell that I factored all that I can here. I took out the greatest common factor, not just any common factor, because there's nothing that these two have in common anymore. So again, to check it, as we talked about while we were doing it, I'm going to distribute. So 5x times x squared is 5x to the third. 5x times 4 is 20x. And this matches what I started out with, so that's good. Okay, let's do a second one. All right, negative 2ab plus 14a squared b to the fifth. Now, when we have a leading coefficient that's negative, so the coefficient is the number in front, when the first one is negative, often we pull that out so the GCF is negative. Okay. Now, in this case, sometimes you can switch them around to have the bigger exponents in the front, but right now we'll just leave it like this, and we'll say we're going to pull out a negative GCF because this number is negative. So if we look at the numbers, what can come out of both of those is 2. So we're going to pull it out as a negative 2. And then I look at the A's. So again, this is an A, and this is A times A, right? What can I take out? I can take out just one A out of each. And then B, again, there's a single B here. There are 5 B's here, but that really doesn't matter because all I can take out is the 1 that they have in common. So negative 2AB ends up being my GCF. Now, if you remember, we said that if there are 2 terms here, there have to be 2 terms here. So you can't just say, well, the whole thing is there, I don't need to include it. Because if I think about it, negative 2AB divided by negative 2AB, it doesn't equal 0, right? Anything divided by itself is going to be 1. So we need to have a 1 here. If you think about it, otherwise there's no placeholder. And when I multiply it back, there would be nothing there to give me this term. Okay, now 14 a squared b to the fifth over negative 2ab. 14 divided by negative 2 is negative 7. A squared divided by a is going to be a. B to the fifth divided by b, remember we subtract those exponents, it's going to be b to the fourth. So here we are in factored form. Okay, again, if we want to check it, we can distribute. And sometimes, depending on how complex the problem is, sometimes you can distribute kind of in your head here and check it, or sometimes it's better to write it out. So negative 2ab times 1 is negative 2ab. Negative 2ab times negative 7ab to the fourth. Negative 2 times negative 7 is positive 14. A times a is a squared. B to the first times b to the fourth is b to the fifth. When I look at this, I see that I ended up with what I started out with. Okay, let's do one more, and then we'll leave the last two for you to do for practice on your own. And again, the answers are on Lumen already, so you can check those after. Okay, so moving on to number 3. We have 3 terms this time. 24x squared BC plus 60 x to the third AB minus 48 x squared ABC. Okay, so it looks just a little more complicated just because there's more of it, but it's nothing that we haven't done already. So when I look at these, I'm going to look at the numbers first. Okay, if you write out the factors of those, you look at them, you will find that 12 goes into each one of those. Okay, so 12 is going to be our greatest common factor for the coefficients or the numbers. Then let's see what else is in all of these? Well, I look at the x's. So this one has 2 of them multiplied, this one has 3, and this one has 2. So I can pull out a group of 2 out of all of them, which again is the smallest of the exponents. So x squared is in my GCF. And then if I look, we have to be careful because c is here and here, and a is here and here, but a is not in all 3 of them, and c is not in all 3 of them. So I can't take it out. It's not a common factor to all of the terms. The only one that is b. And it's just b to the first power, because that's all that any of them have. So now I'm going to have 3 terms here to get me back to this, right? So we can write out 24 x squared bc over 12x squared b. 24 divided by 12 is going to be 2. X squared divided by x squared is going to cancel out. Same with b. I have c. So I have 2c. Even at this point, you can stop and distribute to make sure you're on the right track. So 12 times 2 is 24. X squared, there's no x's here, so I would just have x squared. Same with b, same with c, right? If I multiplied these, none of those variables would change because there aren't those variables in both spots. Okay, here, 60 divided by 12 is going to be 5. X cubed, I take out x squared, I have x left. A didn't get taken out at all. B got canceled out. Again, if you're not sure what we're seeing there, you can always write it out like this, and I would encourage it if you need to, especially for the trickier ones. And then finally, negative 48 divided by 12 is going to be a negative 4. X squared cancels out. A does not. B does. C does not. And again, to check it, we would distribute it back, which is a really good idea to do because you can easily check it. Okay, so number 4 and 5, again, there's nothing in there that we haven't done already. So try those on your own. Check your answers on Lumen, on the answer key. And if you have questions, then please make sure you ask me. All right, so that is factoring out a GCF, okay? And that is actually the first step we will want to do with every factoring problem. No matter what other kind of stuff we have to do, we always want to factor out a GCF. So I'm just going to make a little list here of all the different factoring methods that we're going to learn in this chapter. And so we can kind of keep track over there. So the first one is factoring out a GCF, and we're always going to do that first. The next thing we're going to talk about is factoring what we call easier trinomials. Okay, so a trinomial means that there are 3 terms. And so we're going to be looking at trinomials in this format. Ax squared plus bx plus c. A, b, and c are numbers. In this case, they'll be integers for us. A is going to be 1. That's what makes it an easier trinomial, is that we have 1x squared here, not 5 or 12 or whatever. We'll get to those later, okay? So before we get to this, I want to review what happens when we multiply some things. So what I would like you to do is copy these down, these 4 multiplication problems. And I'm going to stop the video in just a second. And I would like you to multiply each of these out. Okay? And you can take 2 steps. So first you can have your 4 terms you get from foiling, and then you can combine like terms. Okay? And then we'll come back and talk about them. But go ahead and do that and kind of think as you're doing it about where those numbers are coming from and if you see any patterns.